All right, hi everyone, it's Mrs. Leopold here again. I'm going to take you through lesson 2.5, which you can see here from the title is all about the inverse of a quadratic function. So we talked a little bit about inverse functions in Unit 1. We talked about them graphically and algebraically, and we're going to expand on that specifically with regard to quadratics today. But first, let's just look at the overall idea and do a little warm-up and remind ourselves about what the inverse is, both graphically, which is number 1, and then algebraically. So graphically, a function and its inverse are mirror images of each other over the line y equals x. So I drew the warm-up down here. I just wrote down what the example was for the warm-up. They gave us the function f of x equals negative 2x plus 1. And then if we have the line y equals x, I just drew it in there. And I graphed the equation, negative 2x plus 1. Remember, this plus 1 is the y-intercept, so I go up positive 1 on the y-axis, and then I go down to right 1, down to right 1, or up to left 1, and that's my equation of the function negative 2x plus 1. So if I'm going to try to find the inverse, well, I would just switch the x and y and regraph those points. So this point right here is 0, 1, so if I make that 1, 0, then there's the point that's equivalent on its inverse. Here I have this point down here, which is 1, negative 1, so I would go negative 1, 1, and there's a point on the inverse. This point down here is 2, negative 3, so I'm going to go left 3, up 2, right, and then this final point up here is negative 1, 3, so I'm going to go 3, negative 1, and so I can see graphically this is my inverse, the purple function. Excuse me. So this purple function is reflected over the line y equals x. So the blue, so if I folded my paper, this blue part would fold on top of this purple part, right? And then you can see hopefully here that this blue part would fold on top of this purple part. So they are mirror images of each other over the line y equals x, and graphically that means these are inverses of each other. Now algebraically, how could I find the inverse? Well, you take this original function, which is negative 2x plus 1 equals f of x. We switch the x and y, and then we solve for y. But the last thing you need to do is to replace the y with the proper notation, which is f to the negative 1 of x. So this is my original y value. I'm going to switch that to x. This is my original x value. I'm going to switch that to y. I'm going to subtract 1 from both sides. Then I'm going to divide everything by negative 2. So I get y equals, but remember, instead of y equals, I'm switching that to f to the negative 1 of x. I have positive 1 divided by negative 2, so I have negative 1 half x. And then I have negative 1 divided by negative 2, which is plus 1 half. So this is the equation for this line over here. And that is how I find my inverse, is I switch the x and y, resolve for y, and then instead of having a y right here, I have to have the inverse notation of x, so we know this is the original y and this is its inverse function. Now how do their domain and range relate to each other? Well, let's see. In my original blue function here, well, this is a bad example because the domain and range for both are all real numbers, but typically they would switch. So the original function's domain would become the new inverse function's range, and the original function's range would become the inverse function's domain. So they switch, or what we were saying before in Unit 1 was they swap, right? Swap or switch, whatever you want to say. Now work number 2 is specifically about your parabola. So we see our parabola, just our traditional parabola, f of x equals x squared. So remember, we have that 1 to 1, 2 to 4 relationship. We go left and right, 1 to 1, left and right 2, and then up 4. And there's the sketch of the original function. So this is my original function. Now how do I do the inverse? Your inverse is when we swap the x and y, right? So on an inverse, the x becomes your y, and the y becomes the x. So the x and y swap. So we look at this ordered pair. Well, 0, 0 swapping is just 0, 0. Here, this ordered pair is 1, 1. When I swap 1, 1, it stays the same as well. This ordered pair is negative 1, 1. So when I swap, that becomes 1, negative 1. So I'm down here. This ordered pair is 2, 4. When I swap, it becomes 4. 1, 2, 3, 4, 2. So it's up here. And then this ordered pair is negative 2, 4. So I go 1, 2, 3, 4, down 2. So when I graph, this purple graph is the inverse. Now, this purple graph, is it a function? Well, hopefully you're saying no, it's not, because it's failing the vertical line test, right? That vertical line is hitting the function, or the not function, sorry, it's hitting the graph in more than one place. So it is not a function. And you knew that from the very beginning, because if the original fails the horizontal line test, right? So if the original fails the horizontal line test, then its inverse will not be a function. So the original needs to be a one-to-one function. This is not a one-to-one function. Therefore, its inverse will not be a function. So how do we know it's not one-to-one? It failed the horizontal line test. So if we are going to find the inverse, even though the inverse isn't a function, we can still find the inverse. We take our original function, we switch the x and y, we resolve for y. Now, how do I isolate my y? Well, if it's y squared, the only thing I can do is take the square root of both sides. When you take the square root of y squared, you just get y. But on the other side, we don't just have square root of x, you have a positive and a negative square root of x, right? If I was trying to get 25, I could square negative 5 and I could square positive 5, and both of those would give me 25. So that is where my plus and minus is coming from. So the inverse function is plus or minus the square root of x. So the positive portion, let's just kind of look at this. The positive portion, actually, let's separate it. Oops, sorry. So if I'm looking at y equals the positive side of square root of x, I'm looking at this upper portion right here, right? And in my graph here, I'm looking at this right-hand side is associated with, the inverse, which is the square root of x. And then if I'm looking at the negative portion, that's the lower part. So the negative square root of x is this left-hand side associated with the left-hand side of the original, which is the lower portion down here, right? So the domain restriction here, it's going x is greater than or equal to 0, but here it was the positive. Oh, you can't see the here, sorry. It's too difficult to explain in this video, but you can ask your teacher about that if you're having some trouble discussing it or understanding. But yeah, have a look here and see how this is breaking down into your positive part and your negative part down here. All right, so is the inverse of a parabola ever a function? Well, technically the answer is no, unless we restrict the domain. So we can make a parabola, the inverse of a parabola, a function if we restrict the domain from the very beginning. So looking at these two examples, this is restricting the domain. Remember, if you had your original function being f of x equals x squared, you would have the right-hand side, which is here, and you'd have the left-hand side, which is here. So if we restrict the domain, for this right-hand side, we're restricting the domain to only be greater than or equal to 0. So my domain is greater than or equal to 0. On this one on the left-hand side, if we're restricting it over here, then my domain would be what? It would be x is less than or equal to 0. So negative infinity to 0. And on this other one, it's 0 to positive infinity. So if I restrict the domain, then it passes both the vertical line test and the horizontal line test. And so now I know if I find the inverse of just this portion, then yes, it will be a function. So I have these points 1, 1, 2, 4, and so I'm going to reverse 1, 1, or I have 0, 0 as well. So 0, 0 becomes 0, 0, 1, 1 stays 1, 1, but 2, 4, we switch the x and y, it becomes 4, 2. So that's my final point that allows me to see that this right here, the purple equation right here, is the inverse of the blue. If I graphed the y equals x line, right, then it's the mirror image over that red line right here. So it's the mirror image. Purple and blue would match on top of each other if I folded my paper on that red line. Therefore, they are inverses of each other. So try this red one, this one over here on the right-hand side. Try that on your own if you want to. Right, we have our y equals x line. We restricted the domain to be less than or equal to 0. I have my points 0, 0. I have my point negative 1, 1. So I reverse that to 1, negative 1. And then I have this point here, negative 2, 4. I reverse that to 4, negative 2. And so this blue graph is the inverse of the function, and it's limited to the domain, the original domain, which is from negative infinity to 0. So now it passed the horizontal line test, the original, passed the horizontal line test, passed the vertical line test. So I know when I graph the inverse, it's also going to be a function. All right, so what are we going to do with this information? Well, let's check it out. So it says, consider the function f of x equals x plus 3, the quantity squared. So I'm just going to go ahead and quickly graph that. So what would happen was I would go to the left, 1, 2, 3. My vertex is negative 3, 0, right? Because there's nothing added here. So this is my vertex right here. And then I would go right 1, left 1, or sorry, right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. And this would technically be my parabola. However, if I'm trying to find the inverse and graph the inverse, then I can't graph the entire parabola. I need to restrict the domain and focus on only half the parabola so it passes the horizontal line test. So far, every parabola that we study will pass the vertical line test, but it fails the horizontal line test, so I have to restrict it to one side or the other. Do you want to go with the positive side, or do you want to go with this negative side? It's up to you. I'm going to go with the positive side in blue. And so if I'm going to go with the positive side in blue, then when I restrict the domain, well, this value is negative 3, and it's going from negative 3 and getting bigger. So I'm including my negative 3, and I'm going toward positive infinity. And I'm calling this the positive side. Now, you didn't have to do this. You could have went from negative infinity to negative 3 and done the red portion, or the negative side. It's going to be up to you, or we're going to tell you within the problem which side to do. Right now, it's our choice, so we went with the positive side. So let's look at part B here. It says, graph the restricted f of x on the grid provided. Well, I already did that. That's my blue portion right here. Right? So this is the restricted portion. And then it says, graph f to the negative x on the same grid. So I'm going to take those ordered pairs. So I have negative 3, 0, and I'm going to switch them to 0, negative 3. So here's that point. I'm going to take the point negative 2, 1, right? That's this point here, and I'm going to switch it to 1, negative 2. So 1, negative 2. And then I'm going to switch, then I have negative 1, and it goes up 4, and I'm going to switch that to 4, negative 1. And I connect these, and that is the inverse function on the grid. And then lastly, it says algebraically determine the equation for its inverse. So this is where people might get confused at the beginning. So we take our original function, which is just x plus 3, the quantity squared. F of x equals x plus 3, the quantity squared. Remember, this is our y, this is our x. So I'm going to switch the x and y. And I'm trying to isolate my new y. Well, the first step I must do here is take the square root of both sides. And when I take the square root of a perfect square, I just get whatever is underneath the square root symbol. So these two, the square root and the perfect square, cancel each other out. And so I just get y plus 3. But on the left-hand side, I need to put a plus or minus. There are always two options. We talked about that on the previous page. There's the positive side, the right-hand side, or the negative side. Now we restricted it to the positive side. So which actual sign do you think we're going to include? So I move my 3 to the other side, which becomes negative 3, and I have my plus or minus x. Except I don't want both of those. We want to see this work. We want to see that you understand that there are two possible sides, the right and left-hand side of the original function. And so now you can see it's going to be the one that goes up or the one that goes down, right? And the upper portion is related to the right side because that's right is positive and up is positive. And the lower portion, I'll color coordinate it here, is associated with the left-hand side. Okay, so once you have limited it up here, then your final answer, right, is going to be whatever side you chose. We chose the positive, the right-hand side, therefore I need my positive symbol here. And so you can leave it like that, or you could have had root x minus 3. It doesn't matter. These are both the correct answer. All right, let's practice that again. This time, we're going to restrict the domain and take the negative side just for something fun and different. So the first thing that you might want to do is graph this, right? So what is your vertex? Your vertex is hk, which is 4, negative 1. So I go to the right 4, 1, 2, 3, 4, down 1. It has a stretch value of 2. That means I go to the right 1, up 2, left 1, up 2, right 2, I usually go up 4, 1, 2, 3, 4, but I'm going to double that distance, 1, 2, 3, 4. So I'm going to go up 8. So I go up 8. So I have my right-hand side of my parabola, or I have my left-hand side of my parabola. Just for fun, let's go ahead and limit it to the left-hand side of the parabola. I don't think the answer key in the notes did that, but let's just do the left-hand side of the parabola. So if I'm going to limit it to the left-hand side of the parabola, then I'm going to go from negative infinity to 4. Right? So I restricted the domain so it passes both the horizontal line test and the vertical line test. And now I want to graph the inverse of h of x on the same grid. So I'm going to list the original h of x coordinates, and then I'm going to list the new inverse coordinates just to make it easier for myself. So the original h of x coordinates were 4, negative 1, and then I have 3, 1, and then I have 2, 7. So I'm going to inverse those, so I'm going to switch the ordered pairs because that's what we do when we're doing it graphically. So I would get negative 1, 4. I would get 1, 3, and I would get 7, 2. And so here is the parabola. And you can see if I graphed the y equals x line, that purple and black graph would be reflective over this line. And if I folded it down this line right here, the y equals x line, that the purple and black would lie right on top of each other. Now remember, we chose the left-hand side of the graph, which was our negative side. You might want to think of it as the negative side. And so naturally then, when we're looking at our parabola, it was the lower part, right? It was the bottom side or the lower side. And that should make sense because the lower side is also going to be negative. It's down is lower or is negative and left is negative. So that should correspond with each other. Now, if I'm actually going to calculate, or sorry, I'm going to algebraically determine the inverse, then I'm going to take the original and I'm going to switch the x and y. So this y becomes x and this x becomes y. And now I need to resolve for y. So the first thing I have to do is add 1 to both sides. So I get x plus 1 equals 2 times y minus 4 squared. Then I need to divide by 2. So I get x plus 1 over 2 equals y minus 4 squared. Then I need to take the square root. So we need to isolate this perfect square so that my last step is to take the square root of both sides. But remember, every time you take the square root of both sides, you have to show us the understanding that you know that creates two different parts of your inverse, the upper portion and the lower portion. So I'm going to continue over here. So I have plus and minus the square root of x plus 1 over 2, and that equals y minus 4. My last step is to add 4 to both sides, so I get 4 plus or minus the square root of x plus 1 over 2 equals y, but then I also have to replace y with the inverse notation. My final step is the answer. Well, what is the actual inverse for the purple graph up there? Is it the positive portion or is it the negative portion? Well, remember, I chose the negative. I went with the left-hand side. And so I'm going to have to go with the lower portion, which is the minus sign this time. So this is my final answer. I don't include both the plus and minus, because if I did, it wouldn't be a function, right? It would go up like this as well. But we only chose the lower portion. That's why I have the minus sign. So this is my final answer. All right, let's try number 3. I'll get you started and then I want you to pause and try it on your own. But really, the first thing you should be thinking of is I see the graph and you should be saying to yourself, okay, if I have the graph, then I can come up with a function that represents this graph. So it says, given the graph of the function below, determine its inverse. So determine an equation of its inverse. So ultimately I want to find the inverse, but I can't find its inverse until I have the actual original function. So now you're looking at a graph and you're going, oh, hey, you know what? I have the vertex, which is negative 3, 5. And if I have the vertex, then the easier notation or the easier equation that I'm going to use for the parabola is the vertex form. So I'm going to have my x minus h squared plus k. But my h is negative 3, my k is 5. So I get f of x equals a minus a negative 3 turns it into a plus 3. And then, of course, my positive 5 turns that into plus 5. The last thing I need to do is get my a value. Oops, I don't know what I pushed. Okay, so the last thing I need to do is get my a value. So how do I get my a value? Well, I have the graph right here, and I can see I went right 1 and down 2, and left 1 and down 2. Instead of having it 1 to 1, I have 1 to 2, and it's going down 2. So hopefully you're saying, okay, it stretched twice as far, and it went down, which means I need to multiply. That's a negative 2 that I need to put as my stretch factor. Right, so I have a negative 2 as my stretch factor. Usually I go to the right 2 and up 4, but I'm going to the right 2 and down 8. So instead of a 2 to 4, I had to multiply that value by 2 and get 8, and then it's going down, so I had to put the negative. So my a value is negative 2. Now that I have my original function, I can find the inverse function. by going ahead and switching my x and y and solving. So go ahead and try that now. All right, did you get these answers down here? Now this was a little confusing, so you can't really use this notation up here, f to the negative 1 of x, unless it's a function. It's only a function if it passes the vertical line test. So if I were to graph both the blue section and the red section, then my inverse would not be a function because it would fail the vertical line test. So I had to choose. Once you switched your x and y and solved, you had to choose. You either had to choose this first one or this second one, but you couldn't have both. I color coordinated it so you could see blue function, inverse function, f to the negative 1 of x. That would be the upper portion because I chose the positive half, or if I chose the negative half, then it would be the lower portion, which is the red part. So you had to choose either one of these. Notice I have my domain restriction here though. Right, it's going from negative infinity to 5, or here I would have restricted my original domain to get it to match up. I would have chosen either the right hand side or the left hand side. So this is associated with the original domain of x is greater than or equal to negative 3, and this one, the original domain, would be from negative infinity to negative 3, but that's the original. But when you're finding the inverse, you don't have to do the original domain right here, you just have to do the inverse domain. Again, it's pretty hard to do on a video, so ask your teacher questions if you're not sure. I know that they would be happy to help. I'm certainly willing to help any of you, so stop by if you have questions or ask during class. Okay, the last thing we're going to do is just some plain old algebra. So it's another way, another strategy for how we can verify that we have inverses. So not only can we switch the x and y, but we could also try this method, which is to take the function notation f of g of x has to equal x. So if we took the function g of x and input it into f of x, then and you get x as a result, you have to reverse it and put the function f of x into g of x. And if you get x as a result, then we know the two functions are inverses of each other. So we call this function composition, right? F of g of x is function composition. G of f of x is function composition. So if we ask you in our directions to show that these are inverses, show whether or not they're inverses through function composition, then you have to do the process that I am about to show you. So I'm going to color coordinate. My f of x is going to be blue. My g of x is going to be red. So if I'm going to calculate f of g of x, that means I'm going to take this red portion, 2x squared minus 1, and I'm going to substitute it into the x of the f of x function. So f of g of x means I'm going to have the square root, and I'm going to input this entire thing, which is 2x squared minus 1, in for the x right here, and then I'm just going to keep my plus 1 divided by 2. Right, so I input the g of x in for the x in my f of x function. Now I'm just going to simplify. Well, what is minus 1 plus 1? Hopefully you're saying those cancel each other out. So I have 2x squared divided by 2 because the minus 1 and plus 1 canceled out. And 2 divided by 2 cancels out. And what is the square root of x squared? Well, that is x. So that did equal x. Now I'm going to do g of f of x. So I'm going to take f of x, which is this entire, let me do some erasing here. I'm going to take f of x, and I'm going to substitute that in to the x of g of x. So my g of x is 2 times x squared minus 1. But instead of putting in an x, I'm going to put f of x function in for my x. So I get 2 times the quantity of the square root of x plus 1 over 2 squared minus 1. Well, remember, square root and squared, these two operations cancel each other out. When you square a square root, it just becomes itself without the square root. So I get 2 times quantity of x plus 1 over 2 minus 1. So what happens, well, this 2 over 1 and this 2 in the denominator, they cancel each other out. So I get x plus 1 minus 1, right? So this is just x plus 1 minus 1. Those plus 1 minus 1 cancels, so I get x. And you must write this statement. If f of g of x equals g of f of x equals x, then they are inverses of each other. So you have to write the statement, if f of g of x equals g of f of x equals x, then we know they are inverses. All right, try this last one on your own. It's a little bit more complex than the one we just did, but go ahead and try the algebra on your own. Pause, do it, and then you can check back with me to see how it went. All right, so whichever direction you went, f of g of x or g of f of x, when I did f of g of x and I simplified here, I substituted in, g of x into my x, so I get 4 times the quantity here plus 2 squared minus 3, and then this positive and negative 2 cancel, and then I square it, but when you square, you have to square the top and the bottom, right? So when you square square root, it just becomes x minus 3 by itself, but you also have to square your 2, which becomes 4, which is awesome because these cancel, which is how I end up with x minus 3 minus 3. But x minus 3 minus 3 is not x, that's x minus 6. As soon as it does not equal x, you could have stopped and just made this conclusion. You don't have to do the other portion because it shouldn't work. If you want to try to do it really quickly just to make sure you didn't make a math error, you could. So I did g of f of x, so I'm going to take this entire function and plug it into x of g of x, which I did here. But I can see there's no way when I take the square root of that, that's going to come out and somehow I'm going to be left with an x. So it's just not going to equal x either. Therefore, f of g of x does not equal g of f of x, and they both do not equal x. Therefore, these functions are definitely not inverses. So sometimes it'll work, sometimes it won't. There was a lot to digest today. Hopefully you can go back through, look at the answer key, look at the work, and certainly ask your teacher if you're confused about anything. All right, thanks. Bye.